Okay, I'm recording now. Okay, sorry guys. So for the people who are going to look at this on YouTube, I forgot to hit record. I've only just started. So there are two ways to write thermochemical equations, and when you write the heat term, the energy term in a chemical reaction, if the energy term is a reactant, it's endothermic. If the energy term is a product, it's exothermic. And that should kind of make sense if you think about what those words mean. Endothermic means it absorbs energy. So the energy would be in the reactants. It's going into the chemical or into the reaction. Exothermic means energy is released. So that would mean the energy is being created as a product. Okay, we'll look at this. Yeah, actually, this is a really good example to kind of help you guys figure this out. So now this is going to be tough because the way my pen is working, it's I'm writing it on D2L, not on PowerPoint. So this will be a little tricky. But what I want here is for you guys to write a thermochemical equation for each reaction below. What I mean is I want you to put the energy term in the reaction. Now, let me just see something here. Okay, so the answers are there. I'm just going to go back and I'll just kind of write, or I'll show you how it works. I'll write it myself. Okay, so this is negative. Sorry. So this means it's clearly exothermic. So because it's negative, because it's exothermic, that means the heat is a product. Now, again, I get this question every year. Students are like, well, why are you writing it as positive when it's clearly a negative number? The negative means that it's exothermic, which means it's a product. Okay, so endothermic heat goes as a reactant. So I would just write my chemicals again. Okay, I would put my heat term now as a reactant. Now, I know you guys have the, if you're following along with, if like maybe you have your notes printed or you have your PowerPoints open on another computer or something, you might have the answer here, but I just want to give you a minute to try this one, the question C. Okay, we have a positive term. I won't say much about it. I'll give you 1 minute to try this, and then I'll check your answer. So I'll be back in 1 minute. Okay, just take another 30 seconds or so to try this. This is pretty quick. All right, so let's see if you guys got the answer to this now. This is going to be hard because I don't have a lot of room to write here. So this is obviously, whoops. Well, okay, there you go. You can see the answer there. That's easier than me writing it. Let me clear my writing so that this screen looks normal. There we go. So there you go. You can see the answers. Sorry. There you go. Again, just really important to note that when we put the numbers into the thermochemical equations, we always write them as positive. And if it's exothermic, it's a reactant, a product. The energy is getting released as a product. If it's endothermic, the energy is a reactant. It's getting absorbed. And this isn't as important, but you'll also notice that when I put it in the equation, I don't include the mole. I just include the energy. That's not really that important. For you guys, I wouldn't take off a mark if you put in kilojoules per mole. But we don't need to put the mole in there when it's in a chemical equation, a thermochemical equation. Cool. So that's really it. I mean, pretty straightforward. So wink, 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 this would be like, excuse me, a good multiple choice. I could give you a thermochemical equation. Like imagine on the test if I gave you this. Sorry about my penmanship there. And I said, is this reaction A, endothermic, B, exothermic, C, something else, and D, none of the above. You get the idea. This one that I circled would obviously be exo, and these down here would be endo. All right, cool. So I feel lost without my PowerPoint. If any of you are wondering, like it looks like a PowerPoint, but I'm running it in the D2L, like I'm running it not through the program itself. So it's really weird to not use my pen. Okay, so this is a good question. This is literally a question that you would have seen in chemistry 1120, just with a little catch. We're adding heat to this. So this is going to be a nightmare maybe for some of you, because I'm throwing back this term for you, everybody's favorite thing from chemistry 1120, the mole ratio. Ooh, I don't know if you guys remember that from 1120. If you guys remember this word, stoichiometry, everybody's favorite chemistry word. It's not as hard as it sounds. So actually, I do have to do a little bit of work here, though. This is not the easiest example. It says, how much heat is produced when 30 grams of methane is combusted in excess oxygen? So, we don't have to worry about limiting reagents. That's a chemistry 1120 problem. I do have a question in the chat. It's a private message, but it says reactions can't be endo or an exo at the same time, and that's absolutely right. It has to be one or the other. Reactions can only be endo or exo. They can't be the same. They can't have both. Okay, so how much heat is produced when 30 grams of methane combusts in excess oxygen? All right, well, first things first, this doesn't have anything to do with the actual question, but if you're curious, this is an exothermic reaction. So the first thing I need to do is to find the moles of methane. Okay, remember when you're using mole ratios, this is again from chemistry 1120. So you do have to remember a little bit of stuff from 1120. Whenever you use a mole ratio, you must find moles. Okay, grams are of no use to us. So can anybody tell me, how do I find the moles of methane? You can let me know in the chat. How do I find moles, N, of methane? All right, I'm getting some chats up here. Yeah, okay, so there's two answers and both are correct in different ways. Aman says mass over molar mass. That's the perfect answer. But Abdul Halim brings up the periodic table. The periodic table, we would need to find molar mass. So you're both correct. I need the periodic table to find molar mass. And then, as Aman said, I will use the formula mass divided by molar mass. This, guys, is from 1120. So if you can't remember that, there is some review from 1120 on your D2L if you wanted to do a little bit of practice or review. Okay.
Sir,
Yes?
isn't it supposed to be endo because it's positive?
No, now, so again, that's the problem that I mentioned that students have on the previous slide. So if you guys didn't hear that, the question was, isn't it endo because it's positive? But remember what I just said. Okay, let me clear my slides here. Okay, exothermic, when you write the delta H term by itself, it's negative. When you put it into an equation, if it's a product, it's exo. When you put it in the equation and it's a reactant, it's endo. But you can't have negative signs in a chemical equation. That's not how chemical equations are written. So yes, it's positive when I put it in. Well, I mean, I don't even want to say it's positive. It just means, like, when you write a chemical equation, the plus sign doesn't mean positive. The plus sign means and. So if you said this in English, it would be the word and. So magnesium and oxygen yield magnesium oxide and 602 kilojoules of heat. So it's not positive. The plus sign just means and. And when you write a heat term as a product, it's exothermic. When you write a heat term as a reactant, it's endothermic. Okay, so when you write thermochemical equations, it's a little different. It can definitely be confusing, but you definitely want to do some review if you're having trouble with this. Okay, so I got a question in the chat. We do not need to find anything about oxygen in this question. We are concerned with methane, not oxygen. Oxygen, we have excess oxygen, so it's irrelevant. We need to worry about methane. So step number one, find the moles of methane. It's mass over molar mass. So it will be 30 divided by the molar mass of methane. Now, guys, I have good news. I will always give you the molar masses on your test. So you do not have to calculate molar masses in this course. You did enough molar mass calculations in chemistry 1120. So the molar mass, if this was a test question, I would give it to you. The molar mass of methane is, let me just save myself some time here. I'll just write it down. 16, sorry guys, I'll get rid of that text in a second. 16.0424 grams per mole. Okay, and let me get rid of that. There we go. So this molar mass will be given to you on a test. You do not need to memorize or calculate molar masses for me. Okay, so I divide that out. Now I know the answers are there, but I'm just going to do this on my calculator because I don't want to just have the answer there. I want to work through it with you. So 0.424. Okay, so I end up getting 1.8700 moles of methane. Now, I can only have 3 significant figures. I wouldn't worry too much on a test about significant figures. You would have to be careful in the lab, though. So watch out for significant figures in your labs. On a test, I don't care. Okay, so guys, I now know the moles of methane. No problem, everybody. Yasmin and Harold, no problem. And no problem, Aman. I'm sure yeah, if you're talking about methane, then you're correct. Okay. So Now, what do you do? Again, this is straight up review from Chemistry 1120. When you know the mole of something in a chemical equation, you know everything else. It's like in a recipe. You know, if I wanted to double a recipe, I need to double all of my ingredients. So a chemical equation is like a recipe, and I know how much methane I have. Oh, I missed my PowerPoint. I know how much methane I have. Okay, so to find the heat of my system, I'm going to take my 1.8700 moles of methane, and I'm going to multiply it by my heat term, 882 kilojoules, and divide it by my number of moles of methane. I have 1 mole methane, and that's it. This, guys, let me pick a different color. This is my mole ratio. Do you guys remember that from Chemistry 1120? It's what you want over what you have, or if you had me or another instructor, you might have heard required over given. This is my mole ratio. So I multiply that out, and let's see what answer I get. Okay, and I will get let me go back to red here. 1,650 joules. You could write it as kilojoules, but that's fine. I could say kilojoules, so I could say it would be 1.65 kilojoules. Whatever. Now, here's the key. This is heat released. Okay, so if I was going to write this as an enthalpy term, it would be negative, but you know, it's just saying how much heat is released or how much heat is produced. It's 1,650 joules, or 1.65 kilojoules of heat released. Yeah, so as no problem, Harold, if you disconnect, that's no problem. And as Aman just said, the number like this number, let me go back to green. Some of you might be wondering, where did I get 1? My pen, please, pen. Where did I get 1? It's because there's 1. Okay, if I was talking about oxygen or water, I would use 2, but again, I use 1 because there's only 1 of them. Okay, let me see if there's another example.
Sir,
Oh, there is another example. Yes?
we don't need to worry about physics, right?
No, you don't.
Even at the test.
No, don't worry about sig figs.
Okay, thank you.
No problem. Okay, let's look at another one. Okay, how about this? Okay, I don't know if you guys are ready. I don't know if you're feeling confident. But you know, if you don't have the answer in front of you, why don't you guys try this one? I'll give you, now this will take a few minutes maybe for some of you to try. You'll notice, oh my gosh, this pen. You'll notice that the molar mass is given to you. Okay, so this says we have 15 grams of HF, and I want you to find out Q, how much heat is required. So I'm going to put myself on mute. The molar mass is given. You don't have to do any looking on your periodic table. Just remember the formula for moles is mass over molar mass. So why don't you guys take 2 to 3 minutes and give this a try. So I'll be back in 2 minutes to see your answer. Okay, good luck. Okay, so let's have a look at this one. Now, you know, I think this might like the question might look actually harder than it is. This is definitely, wink, wink, a test question. So definitely make sure you know this. I'll put a little star there, but it's not hard. There's 2 steps. Step number 1, find moles. Step number 2, use what's called the mole ratio to find the heat. Before I get into the answer, just look at this equation. For like, if I was going to break this down in as like an English sentence, for every 2 moles of HF, of hydrogen fluoride, I need, or this could be hydrofluoric acid even, I need 273 kilojoules of heat. Okay, so again, that's my recipe. For every 2 moles of HF, I need 273 kilojoules of heat. That's my recipe. The problem is I don't have 2 moles of HF. I need to see how many moles of HF do I actually have. So it's mass, that's a G, over molar mass. That's one formula, guys, you really can't forget about in chemistry 1120 and 1121 and chemistry 2420 or whatever chemistry you guys go on to do after this. That's one of the formulas you'll always need, mass over molar mass. So I divide that out and I get 0.74976 moles. I'm keeping a few extra significant figures, but I know I can only have 3. Okay, step number 2, and let me check the chat here to make sure I didn't make a mistake because I have been known to do that. Oh, okay. So I got a private message in the chat, but that's a really good question for everybody. The question was, will the equation be balanced? And yes. So I know up earlier, Yasmin and Harold were happy to hear that I will give you molar masses. I will also balance equations. So let me say that again. On your tests in Chemistry 1121, the equations will be balanced for you, and I will give you molar masses. And that's not really to make it like, I'm not trying to make things too easy. I'm just trying to save you time because you guys balanced equations and calculated molar mass in chemistry 1120 1,000 times. So I'm just trying to kind of make it more efficient. So I will balance equations and I will give you molar masses. So this is actually a very, very good representation, there's my wink face, of what your test question will look like. It's a balanced equation, molar mass is given. All right, so now Q. I want to find my heat. Well, I know that I have 0.74976 moles of HF. Remember, my recipe is for every 2 moles of HF, I get 273 kilojoules of heat, or I need 273. Well, I don't have 2 moles, I have 0.74. So I'm going to multiply that by what's called my mole ratio. Divide it by divide it by 2. And there's my answer. So I multiply that by 273. Now, some of you might be wondering, why is it divided by 2? It's because there's a 2 right in front of the HF. So I multiply my number by 273 divided by 2, and I'll get my answer 102 kilojoules. All right, that's it. Done. Halas, finished. Pretty easy. There are practice problems on this. If any of you guys think that you need more practice, you can check out the practice problems on D2L. And I think that's it. I don't think there's another slide after this, is there? Oh, there is. There's one more. Okay. Well, guys, let me just go back. I think it's 12:13. I think that's enough for us today. You know, I don't want to overload you with too much information. We will finish chapter 2 by next week, probably by Tuesday's class, which means on Thursday we can do review. But what I want, your homework, not that you actually have homework with me, but over the weekend, I would like it if you guys tried this example. This is a little, it's not hard at all. There's a catch to this question, and the catch is that the heat term is not in the equation. You guys have to put it in the equation first. I won't say much else about that. So over the weekend, you guys should try this question. But other than that, that's it. Yeah, we're done. I have another question in the chat there. These are it's a private message, so you guys can't see it. But yeah, I'll be around for my office hours if you want to join in. They start at 12:30. I'm gonna, probably make a coffee or something. But I will be around at 12:30 if you want to join in. Aman, I mentioned the date of the test at the beginning of class. It's Sunday. Because I have students in quarantine, I was told by my boss we have to have it on Sunday. All right, guys, so that's it. I'll make a post on D2L about the test, just to remind everybody who's not here. But that's it for today.
Sir?
Yep, Aman, I already answered that. If you scroll up, it's 4:30. Same time as class. Yes, there's a question.
How many questions will be for the test? Like how many multiple choice and how many written questions?
I can let you know that on Sunday once the test is made. I'm going to make the test this weekend. So ask me again on Sunday how many questions, and I can let you know for sure.
All right, thank you.
All right, perfect. All right, guys, cool. Have a great weekend. To the student looking for my office hours, I'll be there in about 15 minutes. I'm just going to take a little break, and I'll be there at 12:30. All right, goodbye, everybody. Have a fantastic weekend. Wash your hands. Stay safe.
Thank you, sir. Have a great weekend.
Yes, you too. Thanks so much. Bye-bye. Wear a mask.